In this video, we are going to discuss the different tree terminologies that you might be already familiar with, or I'm just going to revisit it. So, what I mean by terminology is what are the different characteristics of a tree, which is like parent, sibling, and all this different terminology or the vocabulary that is associated with trees. So, whenever you are given a particular problem, let's say if you go into industry or if you are trying to model something, you should already know this terminology. The first thing we are going to discuss is the root element. So the root is the topmost element in a particular tree, or the node that is at the top is called root, which is in this case, the root is 25. The next one is children, which is successors of a node are called children. So in this case, 2 and 51 are children of 25, while 5, 11, 14, and 65, these are children of 2 and 51, respectively. The next one, like here we can see like this is 51 is the child of 25, and so on. The next one is parent. So parents are basically predecessors of a node, which is in this case 51. Let's say if this node is 51, the parent of 51 is 25. Similarly, parent of 2 is 25. So every child has one parent except the root, because the root has no parents, which is 25 will have no parents. 5, 11 has parents 2, while 14 and 65 have parents 51. Another thing we need to know is the grandparent. Again, like most of the tree terminology derives from your exact like family tree. So you could think of this like this is pretty intuitive. You don't need to memorize a lot of these, except for a few like that we are going to see that are very specific to trees, like heights and levels. But typically, like the terminology or the vocabulary is pretty consistent with your family tree. So grandparent, so a predecessors of a node's parent are is called a grandparent, which is in this case 65 and 14 will have its grandparent as 25 because it's the parent of a parent. Similarly, 5 and 11 will also be will also have the common grandparent as 25. Another terminology that's frequently used is the grandchild, which is 25 will have all these four grandchilds. Next, we have this terminology of sibling, which is all nodes that have same parent nodes are siblings, which is in this case 14 and 65 are siblings and 5 and 11 are siblings. So what can we say about 11 and 14? Are they siblings? Uh, Actually, that's false because they do not have a common parent. 5 and 11's parent is 2, while 14 and 65's parent is 51. Next, we have this terminology of ancestor, which is all nodes that can be reached by moving only in the upward direction in the tree. So, what it means is, let's say if we talk about 65, 51, and 25 are going to be its ancestors, which is all the nodes that are there in the path from that node to the root. Similarly, for 2, there'll be only one ancestor, which is 25. And for 5, there'll be two ancestors, 2 and 25. So again, 25 and 51 are ancestors of both 14. Coming to descendants, nodes that can be reached by moving only in a downward direction are descendants. So in this case, if we talk about 25, its descendants would be all of these nodes, because if you go downward, you can reach any particular node. But let's say if it had this 25 was connected to another number like 14, and this had something on the right hand side, like let's call this 55, then the descendants, like 55 would not be the descendant of 25 because it's in a completely different direction and you cannot reach 55 by moving downward. So here 14 is a descendant of 25 and 51. So it has like two different descendants. The next one is leaf. So nodes with no children are called leaf nodes or external nodes. So in this example, 5, 11, 14, and 65 are leaf nodes because they do not have any children. These are also called internal nodes, while uh, these are also called external nodes, while these nodes that are there on the top, these are called internal nodes. So leaves are called external because they are outward, while anything that is a non-leaf, that's called an internal node. So in this case, 25, 51, and 2 are internal nodes, while these four were the leaf nodes as we just discussed. So coming to the next one, the subtree. A subtree of a node is a tree whose root is the child of that node. So what I mean by that is, in this case, if we talk about 25 as a larger tree, it has two different subtrees, which is this one and this one. When we talk about 51, it has one different subtree, the 65. And when we talk about this number 2, it has two different subtrees, one with 5 and the other one that's rooted at 11. The next one is called level or depth. So the level of a node is the distance of that node from the root, which is in case of, let's talk about the base case. Now, for 25, which is the root, the distance from the root should be like 0. While if we talk about 2 and 51, for them, the level is 1 because the distance from root is 1. And finally, if we talk about the last, the leaf nodes in this particular tree, 5 is separated from the root node by two nodes. So that's why its level is going to be 2. So in this case, like every level is, it begins with 0. And we have this neat formula, which is if the root node n is root, then the level is 0. Otherwise, the level is level of the parent plus 1, which is in this case, like let's say if I want to find out the level of this, you can find out this level by calculating 1 plus the level of its parent, which is the level of 51. And now this is again a recursive definition, which is level of 51 is again 1 plus level of 25. And we know that 25 is a root element, so it will be like 1 plus 1 plus 0, which is 2. So it's kind of a neat recursive formula. Whenever we are computing something in trees, as we are going to see very soon, most of these equations translate into neat recursions. So the best way to find out, like add, insert, or remove any particular element from a tree is to write recursive programs. The last one is height, which is the height of a tree is the number of nodes in the longest path from the root node to a leaf node. So if we talk about the path from 25 to 2, like first, what are the leaf nodes? The leaf nodes is 2, the leaf node is 14, the leaf is 65 because it doesn't have children. So the height of the tree is the number of nodes in the longest path. So in this case, there's just one element in the longest path, right? Another way is like you can traverse to the leaf by through this route, which has two different nodes. And another way is this way. So again, this one has two routes. So basically, the height is equal to uh, the maximum number of nodes that are encountered till you reach the leaves. So in this case, the height would be 3 because we have 3 nodes in the route from beginning to the ending, or from the root to the leaf. Now, one thing to note here is a lot of books follow the zero convention, and other books follow one convention, which is the height of the root node is 0 or 1. So you can follow any convention. I don't want to confuse you. I'm going to use the one convention, which is the root. Let's say if there's just one node in a particular tree, in that case the height is 1, which is the if there's just root element, the height is 1. If there's no root element and the tree is pointing, so in that case the height is 0. um, Again, in some books they follow this convention that if there's just one node, then it is 0, and if there's no nodes, then it's -1. So like you can use either convention in the exam. I won't be confusing you. I'll be stating you, if there's just one node, consider it to begin with height 1, or if there's one node, consider it to begin with height 0, because like different books follow different terminology and you can use either one of them. Now again, the height can be calculated against by a neat recursive formula, which is if the tree has just the root, then the height is 1. Otherwise, it is 1 plus maximum of the height of its subtrees, which is like each of these children are basically like subtrees, right? Like they might be more than this. So the height is 1 plus maximum of height of each of the subtrees. So this height of children will basically give you an array kind of each subtree. So in this case, let's talk about this 25. So this has two different subtrees, which is height of 2 and then height of 51. I'm going to erase and maybe do it more cleanly. So basically, uh, we have height of 25 is equal to 1 plus maximum height of 2 comma height of 51. So I'm running out of space, so I'll just write it here. So this can be further simplified to 1 plus max. Now height of 2 is basically 1 because it's the root element when we are just considering this position. And again, like there will be something like height of 51 can be expanded to 1 plus max height of 14 comma height of 65. So if you simplify this, it would be something like 1 plus max 1 comma 1 plus. Now both of these are like 1, so you can take either one of them because again, like these are root elements. So in this case it would be something like 1 plus max of 1 comma 2. So since 2 is a bigger number, it would be simply like 1 plus 2, which is 3 in this case. In the next video, we're going to discuss what are the different types of trees.